Hello, my name is John David Traylor. Today I will be doing a video on the periodic table. This is for my teacher, Miss Jennifer Loeb. During this lesson, it is advised to take notes because there will be a quiz afterwards that you will have to take. The first thing I'm going to go over with the periodic table is what it's composed of. Okay, you got different parts of the periodic table that vary among the board. You've got nonmetals, alkali metals, alkaline metals, transition metals, rare earth metals, noble gases, metalloids, halogens, and other metals. These are very important to know. It's very important to know how to divide the table up into these different parts, especially because certain parts of the board, metals tend to be solids. You want to know the difference because each group tends to have a different characteristics, solid, liquid, or gas, their boiling points, different things like that, so that's important. The table is also categorized into groups and periods. Groups which run up and down, and periods which run from side to side. Now what these pretty much define is when you're talking about, you're talking about like periods, for instance. The periods, which are the ones that run left or right, they're called periods. The period number of an element signifies the highest unexcited energy level for an electron in this element. The number of elements in a period increases as you move down the periodic table because there are more sublevels per level as the energy level of an atom increases. When you're talking more about groups, groups are defined more as by their outer electron shells. For example, hydrogen has one valence electron in its outer shell. Also, lithium, sodium, potassium, and further down in that group. Now, if you move further down the table to like beryllium, magnesium, calcium, strontium, those have two in their outer valence electron shells. And as you go down, you gain more. So that's very important to know when you're going over the periodic table. And going even further into the periodic table, you're going to have the different parts of a specific element. For example, at the very top you have the atomic number. Cobalt, the atomic number is 27. This atomic number represents the number of protons found in the nucleus of an atom of that element, and therefore identical to the charge number of the nucleus. So what it's pretty much telling you is it tells you the charge number of the nucleus as well as the protons, which is very important to know. Below that you've got the symbol. The symbol pretty much represents a simplified version of the actual name. Now the symbol represents, if you were writing out chemical equations, it's very useful to use a symbol rather than writing out the actual name, so you can write things down quicker and solve things easier. Then again, moving further down, you have your atomic weight. The atomic weight is the mass of the atomic particle, subatomic particles of molecules. The protons and neutrons account for most of the mass of an atom. So when you're talking about the protons and the neutrons are going to be the majority of what the atomic weight is going to be. The electrons are going to take up for some of it, but a very minuscule amount. And then below that you have the elemental name. And that would be, for instance, silver, potassium, sodium, nitrogen. Any of these are a name, and that pretty much just describes the element as it is and what it's named for. Moving on, you have another key important fact about the periodic table is you talk about an element. What is an element necessarily? Well, an element is any one type of atom. For example, iron would be an element. Any of these would be an element, really, because it's just a certain amount of that atom. So it doesn't matter how many of that atom it is, but it's an element if it just contains that one type of atom, which is important to know. And another important fact when you're going over the periodic table is ionization energy. And ionization energy increases from bottom to top and from left to right. So you're going to go from bottom to top and left to right. And this is important because what the atoms are trying to reach is they're trying to reach the number 8. The number 8 in valence electrons. Valence electrons are very important for atoms to reach because when you have 8 valence electrons, you're the most stable that you could possibly be. So it's very important that you reach 8 valence electrons because otherwise it's going to be a very unstable atom. I hope this video helped you. There will be a quiz after this, so I hope you took good notes.